Hello class and welcome to section 8.1, multiplying and dividing rational expressions. To be a rational expression means that you are written as a ratio or as a fraction. So we're going to be looking at expressions that involve fractions. So let's go ahead and look at the example we have here. The goodie shop sells candy and nuts by the pound. One item is a mixture made with 8 pounds of peanuts and 5 pounds of cashews. Okay. Therefore it says that 8/13 of the mixture is peanuts. So the reason they come up with this is because we have peanuts over the total amount. Okay, so for them there's 8 pounds of peanuts, and then the total amount is there's 8 pounds of peanuts plus 5 pounds of cashews. 8 plus 5 is 13. Okay, so now if the store manager adds an additional X pounds of peanuts to the mixture, write a new ratio to show the portion of the mix is peanuts. Okay, well, in order to do this, if we're adding X pounds of peanuts, well, my numerator represents peanuts, so I would have to add X to the numerator. And if I'm adding X peanuts, I'm also adding that to the total. So 8 over X plus 13 over X, that would be my new ratio. Okay, so this is an example of a rational expression. Okay, so our next slide tells us what a rational expression is. It is a ratio of two polynomial expressions. Okay, so here is my ratio of two polynomial expressions. So we have a polynomial in the numerator and a polynomial in the denominator. That's what makes it a rational expression. When we multiply rational expressions, okay, we'll be multiplying the numerators and then you multiply the denominators. Okay, and then we're going to go ahead and simplify. So in this case, you could just go ahead and you would write, I'm going to write it right here. You would write, it'd be 5x times x minus 2 all over x plus 1 times x minus 1. That's how you would multiply the rational expressions. Then to divide rational expressions, what you're going to do is you're going to go ahead and multiply by the reciprocal of the divisor. Okay, so in this case, if I wanted to go ahead and divide, I would have to rewrite this and then I could multiply. The way you would rewrite this, okay, is you would have 5x over x plus 1, and then you would multiply it by the reciprocal. So to be the reciprocal, you flip it. So it'd be x minus 1 over x minus 2. And then you'd multiply across like we did in the previous example. So some things to keep in mind while we're simplifying. First thing we want to do is factor if you can. Okay, then we're going to cancel things out, and then we're going to multiply, divide, add, subtract, and then once again we're going to factor or simplify if we can. All right, so let's go ahead and look at some examples. Example 1, we want to simplify the rational expressions. Well, I would just go ahead and look at my numbers. 15 and 5, those are both divisible by 5. So 15 divided by 5 is 3, 5 divided by 5 is 1. 4 and 16 are both divisible by 4, so 4 divided by 4 is 1. 16 divided by 4 is 4. Then I'm going to go ahead and rewrite. I would have 1 times 3, which will give me 3, and then 1 times 4, which gives me 4. And I'm just going to go ahead and simplify. I would have a times b squared, which gives me a b squared. And here I would have b times a to the third, which gives me a to the third b. Now we need to go ahead and continue to simplify. I look at my numbers, 3 over 4. That is simplified as far as it can be. So I'm going to leave it as 3 over 4. Now, I look at my variables. I have a and a to the third. This is really a to the first. I always go ahead and bring my exponent to my larger exponent. So the larger exponent's in the denominator. So it would be 3 minus 1, which would give me a to the second. Okay. Then I look at my b's. I have b to the second and b to the first. Once again, bring to the larger exponent. The larger exponent is 2, and subtract. So 2 minus 1 is 1, so I would just have b. So my answer for this one would be 3b over 4a squared. Example 2. We want to go ahead and simplify, but we need to be careful because in this case we have division. Okay? So remember, in order to divide, we need to multiply by the reciprocal. So it's 4x squared y over 15a to the third b to the third times, now this is where my reciprocal comes into play, 5ab to the third over 2xy squared. Okay, let's go ahead and just simplify our numbers for now. We have 5 and 15, both divisible by 5, so this gives me 1. This gives me 3. 4 and 2, both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So I have 2 times 1, which gives me 2. 3 times 1 gives me 3 in my denominator. Now let's just go ahead and simplify by multiplying across. I like to put them in alphabetical order. So I'm going to have a, b to the third, x squared y, and my denominator, a to the third, b to the third, x, y squared. Okay, so I look at my numbers. Sorry about that. Okay, so I look at my numbers. The numbers are simplified all the way. So now I'm going to go ahead and simplify the letters. So I would have 2 over 3. I have a to the third. So I have an a to the first. So I bring it the smaller to the larger. So it'd be a to the 3 minus 1. So I would have a to the second. Now I look at my b's. I have b to the third and b to the third. Well, they're exactly the same, so they will cancel. The other way you could think about it is if I bring a 3 to a 3, I'd have 3 to the 0. Sorry, 3 minus 3, which is 0. So b to the 0 will give me 1. Now I move on to my x's. I have x squared and x to the first. Bring the smaller to the larger, so I have 2 minus 1, which gives me x to the first. And lastly, I have y to the first and y to the second, so I bring the smaller to the larger, and 2 minus 1 is 1. Okay, so this is an x to the first, so I'm just going to rewrite. My final answer, we don't usually write x to the first, we're just going to have 2x over 3a squared y. There is my simplified answer for example 2. Example 3. This one is multiplying, so let's go ahead and look at our numbers, see what can cancel here. I have 15 and 5, both divisible by 5. 8 and 12, both divisible by 4. So this will give me 2, this gives me 3. So I would have 2 times 3, which gives me 6, over 1 times 3 gives me 3. So now I have m squared. N times n will give me n squared, r. All over, I have an r squared, an m to the third, and an n squared. So m to the third, n squared, r squared. And let's just simplify from here. 6 over 3, both divisible by 3. So I would have 2 and 1. M squared, m to the third. So I bring the smaller to the larger. So I'm bringing this one down. So it'd be 3 minus 2, which is 1. So I have m to the first. Now my n's, they're both n squared, so they cancel out. And now my r's, this is r to the first, r to the second. I bring the smaller to the larger and subtract. So it's going to be in the denominator. 2 minus 1 is 1. So let's simplify this. It's going to be 2 over m r. There is my answer for example 3. Example 4. Once again, we got to be careful. This one's division. So we need to go ahead and multiply by the reciprocal. So we have 18ab squared over 25x squared y to the third times 10xy 9b. Looking at my numbers, 18 and 9 both divisible by 9. 10 and 25 are both divisible by 5. So 25 divided by 5 is 5. 10 divided by 5 is 2. I go ahead and multiply across. I have 2 times 2, which gives me 4. Then I have a b squared xy all over. 5 times 1 is 5. And then I would have, there's no a, so I'd have b x squared y to the third. And now I'm going to go ahead and simplify. 4 over 5. That is as simplified as it can be, so I will have 4 over 5. My a, there's no a's to cancel, so we're going to have an a. Now b squared and b to the first. Bring the smaller to the larger, so it's going to be in the numerator. 2 minus 1 is 1. I have an x to the first and an x squared. Bring the smaller to the larger, so it'll be in the denominator. 2 minus 1 is 1. Then I have my y to the first, y to the third. Bring your smaller to your larger, so it'll be in the denominator. And then it's 3 minus 1, which is 2. I'm just going to rewrite this because we won't write b to the first. We just write 4ab over 5xy squared. There is my answer for example 4. Example 5 and 6 would now be a great time for you to pause the video and try 5 and 6 on your own, and then come back and I'll go over 5 and 6. Okay, so looking at example 5, once again I start out with my numbers. I have 16 and 8 both divisible by 8, so I would have 1 and 2. 9 and 27 both divisible by 9, so I have 1 and 3. So I would have 1 times 1, so I would have 1 in my numerator. I'm not going to write it this time because I wouldn't write typically 1. Then I would have 2 times 3, which gives me 6. Now let's look at multiply across. So I would have a squared b, m squared n to the third, all over a b to the fourth, m to the fifth, n. And now let's go ahead and simplify and see what I have here. So still going to have 6. My a's, this is an a to the first and the bottom, so bring the smaller to the larger, so it'll be in the numerator, and then it'd be 2 minus 1, which gives you 1. Okay, b to the first, b to the fourth, bring your smaller to your larger and subtract, so 4 minus 1 will give me 3. Now look at my m's, my larger's in the denominator, so I'm going to have m in the bottom, so it'd be 5 minus 2, which gives me 3. And then lastly, my n's, I have n to the first and n to the third. The larger's in the numerator, so it'd be 3 minus 1, which gives me n to the second. So my final answer is a, n squared, over 6, b to the third, m to the third, for example 5. Example 6, right away I notice it's division, so I'm going to have to go and rewrite. Okay, so it's 14pq squared over 15w to the 7th, z to the 3rd, times 35w to the 3rd, z to the 8th, over 21p to the 3rd q. Now let's go ahead and simplify numbers. 15 and 35, both divisible by 5. This one will give me 7. This gives me 3. 14 and 21 are both divisible by 7. This gives me 2. This gives me 3. Then I multiply. 2 times 7 is 14. 3 times 3 is 9. Now I'm going to go ahead and just multiply across. I would have p q squared, w to the 3rd, z to the 8th, all over p to the 3rd q, w to the 7th, z to the 3rd. And now let's go ahead and simplify. 14 over 9, that does not simplify any further, so I would have 14 over 9. This is a p to the first, so bring the smaller to the larger, so it'll be in the denominator. 3 minus 1 is 2. Now I have my q, I have q to the first and q to the second. The larger is in the numerator, so q will be in the numerator. So 2 minus 1 is 1. Now my w is my larger is in the denominator, so I would bring the 3 to the 7, so 7 minus 3 is 4. And lastly, my z's. I have 8 in the numerator and 3 in the denominator, so it's going to be in the numerator. Bigger is in the numerator. 8 minus 3 is 5. Okay, so let's just rewrite this. So it'd be 14q z to the 5th all over 9 p to the 2nd w to the 4th. That is my final answer for example 6. If you have any questions on the front side of the note sheet, please write them down now and ask me if you have any questions when you get to class. Otherwise, we're going to move on to the back side of the note sheet. Okay, we have a little bit of reviewing, factoring review, because we love factoring. Okay, just remember that if I have a trinomial, okay, that means there's 3 pieces here, an x squared, an x, and then just a number or a constant. It's going to factor into 2 binomials. So remember, it has to multiply to 12, and then add to -4. So multiply to -12, add to -4. So let's go ahead and break this one apart. So it multiplies to -12 but adds to -4. Well, -6 and +2, that would add to -4. And when I multiply them, they give me -12. Okay. If I look at 8, what multiplies to 2 and adds to 3. Well, that's nice because there's only one thing that multiplies to 2, 2 times 1. And if they're both positive, they will add to 3. So there's that one factored. If you look at example 9, this one's a little bit different. This is a binomial. 7 and 8 were trinomials. There's 3 pieces. This one's a binomial. So what you want to do is take out the greatest common factor. Well, they're both divisible by 4, so I'd have a 4 out, and they both have an x squared. So that means I would have x plus 12 divided by 4 is 3. And then if you were to check, if you were to redistribute, you would get back to what we have here. So here is my factored form for example 9. Okay. Example 10, we're going to go ahead and once again continue simplifying rational expressions by when they're being multiplied or divided. But in this case, we need to go ahead and factor. Okay, so if we look at 10, that numerator, I need to go ahead and factor that. What multiplies to negative 8, okay, but adds to 2? Well, that's going to be a positive 4 and a negative 2 all over my denominator. What multiplies to 3 but adds to 4? Well, the nice thing is 3 times 1 is the only thing that will get me to 3 when I multiply. Okay, times, now I look up here, this top piece, factor out of 3. That's my greatest common factor, so I would have 3 times x plus 1 all over x minus 2. Now that it's all factored, I can go ahead and cancel what can be canceled. So if there's 1 in the numerator or 1 in the denominator anywhere, then you can cancel it. Okay, so this guy and this guy, x minus 2's, there's 1 in the numerator, 1 in the denominator, they will cancel. X plus 1, there's 1 in the denominator and in the numerator, so they will cancel. These two will not cancel because it's plus 4 and plus 3, so I multiply across. So I would have 3 times x plus 4 all over x plus 3. And that would be my final simplified answer because nothing else can simplify or cancel. Okay. Example 11, once again, got to be careful. It is division, so we need to multiply by the reciprocal. So I'm going to rewrite the left-hand side. And it's going to be multiplied by the reciprocal. Okay, so this is going to give me x squared minus 9 all over x squared plus x minus 12. Now I need to go ahead and factor. X plus 2, x plus 3, those are already simplified as far as I can. Can't factor anything else out of there. Okay, now I need to go ahead here. X squared minus 9, that's my difference of perfect squares. Okay, so the square root of 9 is 3, and then it's always a plus and a minus. All over the denominator, what multiplies to negative 12 but adds to positive 1? Well, positive 4 and negative 3, that would work there. Now I'm going to go ahead and do my canceling. Okay, x plus 3, those cancel. X minus 3, so those cancel. And there's nothing else that will cancel, so across my numerator, I just have x plus 2. Across my denominator, I just have x plus 4. So this is my final answer for example 11. Example 12, we are multiplying here. So I'm going to go ahead and rewrite with the factored form. So y minus 1 can't factor anything out of here. If I look at this part, though, they're both divisible by 5, so I'm going to factor out of 5. So it would be y plus 3 times, now we're going to factor this trinomial. What multiplies to 6 but adds to 5? 2 times 3 gives me 6, but it adds 2 plus 3 is 5, so there goes. There's that answer. And then the next one, we have to have what multiplies to negative 5 but adds to 4. Well, there's only one thing that will multiply to 5, that's 5 and 1. To be a positive 4, I have to have plus 5 minus 1. Now I can go ahead and do my canceling. Y minus 1, those will cancel. Y plus 3, these will not cancel, so my final answer will be y plus 2 all over 5, y plus 5. So this answer would be fine. I would also let you know that if you distributed this 5 and wrote 5y plus 25, that answer would also be equally accepted. Okay, just so you know that there's the difference between the two. Okay. And example 13. Simplify the rational expression. So same thing except for this one's division. So we have to multiply by the reciprocal. Okay, so I'm going to do the factoring and writing the reciprocal out, this right in one step. So for the first one, what multiplies to negative 35 but adds to 2? Well, that's going to be 7 and negative 5 all over. This is a difference of perfect squares. So the square root of 4 is 2, so it's going to be plus 2 and minus 2 times, see, now we're going to write the reciprocal, x plus 2 over x minus 5. And I go ahead and cancel. X plus 2's cancel. X minus 5's cancel. So across my numerator, all I have left is x plus 7 and my denominator is x minus 2. So there is my example. There is my final answer for example 13. Okay. There's one last thing we need to go ahead and talk about, and that is the complex fraction. What a complex fraction is a fraction inside of a fraction. Okay, so complex fraction, we're going to write this down, a fraction within a fraction. All right, so in order to take care of a complex fraction, you multiply by the reciprocal of the denominator. So this piece here, this is my denominator. So in order to solve this problem, I'm going to multiply by the reciprocal on the numerator and the denominator. Okay, so see, these would cancel. So I would just be left with x over 3 times x squared plus 1 over x. And then you can simplify it even a little bit further to get my final answer. The x's will cancel. So we have x squared plus 1 over 3. So that's how you handle a complex fraction. So we have a few examples with a complex fraction involved. So let's go ahead and take a look at those. All right, example 14. So we have a complex fraction. We have a fraction in the numerator and a fraction in the denominator. So we need to go ahead and multiply by the reciprocal. Okay, so I rewrite the numerator. It's going to be multiplied by x minus 5y all over x. Okay, so I look at my left-hand fraction numerator, and it's just going to be x squared. Now this bottom piece, this is you got to be very careful with this. This will come up more often now that I'm going to show you an example. So make sure you're paying attention. It's a difference of perfect squares. The square root of x squared will just give me x. Okay, the square root of 25 is 5. And the square root of y squared is y. Now, just like any difference of perfect squares, there's always a plus and a minus. So it's x plus 5y times x minus 5y. Okay. Now I'm going to go ahead and see if there's anything that can factor out of here. No, so I just have x minus 5y all over x. Now I go ahead and cancel x minus 5y's. Those will cancel. Then I have x squared and x. This is really x to the first. So we always bring the bring the smaller to the larger, so I will have 2 minus 1 in my numerator, so I will just have x over x plus 5y. And there is my final answer for example 14. Example 15. Once again, it's a complex fraction, so let's go ahead and rewrite it. In the process, let's also do the factoring. So I'm going to put the left-hand side, x plus 3 squared, it's really x plus 3 times x plus 3, so I'm just rewriting it out, all over x squared minus 6. That's a difference of perfect squares. So it's x minus 4, x plus 4, times, now this is where we have to go ahead, we multiply by the reciprocal. So it's x plus 4 over x plus 3. And we go ahead and cancel. My x plus 4's will cancel, the x plus 3's will cancel, and so all I am left with is x plus 3 over x minus 4. Okay. All right, so there is our examples with complex fraction. We have one more example left to do. If you need to maybe pause the video and just take a few-minute break, go ahead. Otherwise, I'm going to finish up with example 16. So it says a parallelogram with area 6x squared minus 7x minus 5 square inches has a base of 3x minus 5 inches. Determine the height of the parallelogram. Well, just to remind you, area of a parallelogram is just base times height. So if I want to find the height, okay, I would divide both sides by the base. So the height is equal to the area divided by the base. So let's go ahead and set this up. My area is 6x squared minus 7x minus 5 over my base, which is 3x minus 5. So I need to divide this, and in order to divide, I need to factor the numerator. Okay, so you can go ahead and use completing the square if you would like to factor this, or you can use guess and check. Totally up to you, but we need to factor this piece. So I'm going to use completing the square to factor the numerator. So just to remind you, it would be 6 times negative 5, which is negative 30. Then I say what multiplies to negative 30 but adds to negative 7. Well, that's negative 10 and 3, so I would just rewrite it as 6x squared minus 10x plus 3x minus 5. And now I go ahead and look at the first side, the first two, and then I look at the second two. The first piece, I can factor out 6 and 10 are both divisible by 2, and they both have an x. So this would give me 3x minus 5 plus, okay, I want whatever I factor out of here to leave me with 3x minus 5. Well, notice this is 3x minus 5, so I'm just going to factor out 1. So my factored form would be what's in parentheses. Just write that once. And then whatever's left, so 2x plus 1. So I'm going to substitute that in to my numerator. So it's going to be 3x minus 5 times 2x plus 1 all over 3x minus 5. I will notice the 3x minus 5s will cancel, and so I'm left with 2x plus 1. So what this tells me is that the height is 2x plus 1, and I would label it inches. So my height is 2x plus 1 inches. Okay. So that will be it for section 8.1 notes. Please, if you have any questions, there's a lot on this note sheet, ask me. Otherwise, have a great day, and I will talk to you later.